session. Okay, so as usual, before we even start, I want to just go straight to VS Code. We are in week 3. Then create a folder for week 3. Week 3. A school start, just week 3. And that's where we are going to do our week 3 practice. I've seen someone on the chat just comment about that. And we prepared Zoom. Everything is ready. Confirm my LMS is also ready. Yeah, thank you. So today, we need a lot of concentration, a little bit of concentration, and we are going to work with control flows and functions in Python. So 1 hour concentration is more than enough. Then the rest will just be practice, questions, just playing around with some code and some music. So I want us to just go straight, and I think it's recording. Yeah, it's recording. Everything is cool. In case I go too fast, let me know. In case you don't understand maybe a certain topic or a certain point that I might make, kindly let me know so that it won't leave you behind and it won't leave you hanging. This, we need a lot of concentration, a little bit of more concentration than the usual days. But again, it's very simple. Very simple. I said in the previous sessions, you don't need to understand, you don't need to know how to write the actual code. You just need to know how you just need to understand how these things mean. If you understand what functions mean, if you understand what control flows mean, then writing the code is just like ABCD. Very simple. Very, very simple. Everything is very simple. At first, it might challenge you. Second time, it will be easier. Third time, fourth time, then everything will be cool with you. Just understand how these things work. Control flows. What are control flows? What are functions? If you basically understand that, and maybe in your mind, you have a screenshot of how a control flow is written, a function is written. Now from there, it's a good progress. Now from there, you can ask your AI to guide you on how to write these control flows. Yeah, so straight into control flows topic 1. There we go, loading, there we go. Control flows or conditional statements in that case. The word conditional statements, we understand everything from top all the way to bottom. What are conditional statements? For example, just a normal example. I want to vie for president. There is a condition there. Yes, I want to vie for president, but what are the conditions? They have to check my age. I must be, depends on the country, 35 and above, that 5 years and above. If I'm not 35 years and above, depending on the country or depending on the condition, then I'm not eligible to vie for presidency, right? That's a condition. That's a condition. So basically conditional statements are just like that. As simple as that. If I win an election with maybe 50%, 50 plus 1%, then I become the president, right? What if I don't win? I don't get the 50 plus 1. That's a condition. I'm not going to be the president, right? Exactly. So those are conditional statements, and they are simple as that. In conditional statements, you just need to understand that. As simple as that. Okay, that's the example that I could give. That's just an example. That's just a basic example of how conditional statements work. Back to programming. You can just read through this statement. It's all what I've defined, but we are going to write an example to see everything like that. Another example in the LMS. If you are hungry, you need to eat. So what is the condition here? Only if I'm hungry, that's when I have to eat. So that's a condition. And those are basically conditional statements. Imagine that's all. Imagine that's all to do with conditional statements. The rest is just writing the code and playing around with different conditions and maybe checking if we have different conditional statements. It is as simple as that. Okay, so in Python, we have three forms of conditional statements, three types of conditional statements in Python that we have, the basic ones. And you have been hearing the example that I've been giving. If I've been insisting on the word if I'm angry, I need to eat. If I don't get 50 plus 1%, I'm not going to be the president. If I'm not 35 years and above, I'm not going to be the president. I've insisted on the word if. Python is just like English-like language. The same way that we speak English, the same way that we were taught in our kindergartens, in our primary school level, in our high school, in our O levels, these are the same words that we use when it comes to Python. The word if. Definitely, if I'm using the word if, I'm going to use if I'm angry, I'm going to eat. Or else. You hear the word else. Or else, I'm going to get the opposite of that. It's as simple as that. So in Python, we have three forms of conditional statements. We have the if statement, if else statement, then if elif else statement. How does the three work? The first one, I can give an example. If I'm hungry, I'm going to eat. What if I don't eat? Definitely nothing happens. Okay? That is the if statement. The if else statement, we have more than one option here. If I'm hungry, I'm going to eat. For example, let's go back into our childhood life. If you are hungry, your guardian is going to feed you, right? And you must eat. Else, you're going to be slapped. So we have two conditions here. You have to eat and swallow, or you are going to get some whips. That's the second condition. The first condition, if I eat, if I don't eat, nothing happens, but I'm still hungry. If I'm going to eat, everything is going to be well, or else I'm going to be whipped so hard. We have the third conditional statement right here. We have more than one option. The first one was only one option, eat. The second one, we had two conditions here, not conditions, but two outcomes. The third one, we have more than two outcomes. It can be two, it can be three, it can be five, it can be a million outcomes. A good example. if I'm still a child, remember that I'm still a child in my childhood. If I'm going to eat, everything is going to be well for me. And my guardian has already promised me that we are going to go out, we are going to play football, you are going to play with the other kids, right? That's condition number one. If I dare not to eat a leaf, I'm going to be whipped so hard. But I still have the third option. I eat, I get slapped, or else if I don't eat, I'm going to get another punishment. Maybe go fetch some water, get some firewood, get some not play with the other kids. We have more than one condition here, more than one outcome. So basically those are the if else, and if a leave statements. You see how simple they are? They are really, really simple. You don't have to struggle. You see the way those examples are just relevant example and they make sense. Exactly. Everything is simple. We just need a lot of concentration just to get the examples and know how to write these statements. Let's get to the code. Now, have in mind, we have three statements. If else, if a leave else statement, right? Just have in mind that. Now, how do you write an if statement in Python? The first condition. This is how we do it. For example, we are going to measure maybe the temperature of a place. Okay. Let's go back to let's go to another example like the weather. If the temperature is more than 30 degrees or whatever measurement that you are going to use, right? If the temperature, if the keyword if temperature is greater than 20, 25, whatever temperature that you set, then of course, maybe if we are creating a system, we are going to tell the user, today it's too hot. You need to get some cocoa. You need to get some Coca-Cola. You need to go and swim. Because the temperature is more than maybe that degree that your body prefers for maybe a certain activity. Maybe it's too hot, you need to reduce your clothes, your dressing. That's exactly what we check. So this is a basic example of if statement, right? Very simple as that. So let's go to our VS Code and try it out. Week 3, I've already prepared this. So if, let me say if.py, the if statement. So first, you declare a variable, and this variable you are going to set it. You're going to give it a standard temperature. Maybe a standard temperature, let's say my favorite temperature for me to go and swim, it's around, maybe let's say 20 degrees Celsius. Okay, depends with my body like that. So if the temperature, this variable is greater than let's say 20, then I want to introduce something here, the use of the full colon. So once we introduce a full colon, that becomes a block of code. So this one is a block of code. What is a block? Generally, from what you know, let's say the simplest example of a block, what can we give? Like the normal one that we use in our construction. You have that one block, right? Or that one brick. That brick has all its particles together. Okay? So once I'm taking that brick and maybe throwing it away, or that stone, it goes together with its content. Everything that is wrapped inside that block or that stone goes together. So that's what a block is. So if I write a block of code, anything that is inside that block of code goes together with that block of code. So basically that's what a block is. From the normal examples that we know, if we have a box and I carry that box, I'm going to carry that box with the content inside or with anything inside that box. Basically, that's what a block is. As simple as ABCD. You see, very simple stuff. So once anything is inside that full colon, then you can write just like that. Simple. Very cool. So let's just run this code and see the output. So do you see any output here? No. Why? Why don't we see any output right here? And we know maybe my standard temperature for swimming is greater than 20. That goes back to mathematics. This one is greater than. Is 20 greater than 20? No, 20 is equal to 20, right? So let's say our temperature here is 24. This is the initial temperature for our weather. So let's run our code and see it's a hot day. You can go and do your stuff, whatever condition that you have here. So let's say my standard temperature is 20 now. It should be greater than or equal to. So that's how you write greater than or equal to. As simple as that. Do you see? Very simple. But as you can see from our code here, it's not giving me the next expectation. We said the temperature is 20 here, and maybe we set our condition should be greater than 20. So once I run this code, there's no output, right? Maybe I wanted my system to tell me two options. If the temperature is greater than 20, it's a good day, you guys, you can go and swim. But what if it's less than 20? I need a notification that will tell me you just need to chill in the house, do some movies, watch some tutorials, and something like that. So I need the next condition. If the temperature is greater than 20 or above 20, then go and swim. Else, just stay in the house. So that's where the else block comes to play. Remember this? Remember this one here? We are done with the if statement. The if else statement. We have a condition and we have a repercussion for that condition. Or we have another alternative for that condition. If I don't meet the first condition, then I have maybe something extra, right? Simple. So now that leads us to the next example. If else dot py. I'm just going to copy this and then build on top of it because it's the same example. So in this example, we have if temperature is greater than 20, it's a hot day. Otherwise, no, we know definitely if it's not greater than 20, it's else. We write like this. It's a cold day, right? As simple as that. If the temperature is greater than 20, then it's a hot day. Else, it's a cold day. So let's run our code and see if we are going to get output. It's a cold day. Yeah, of course, the temperature is not greater than 20. But if we add 20.5, something like that, a slight change, it says it's a hot day. So basically, that's what if else statement does. As you can see, just as I promised, it's as simple as it looks like. Very simple. As simple as it looks like. The third example, then I check if you have any questions, is the if a leaf, where is it? A leaf.py. So this is the condition with more than one. As you can see, there's some slight change here. It's if a leaf. You see the a leaf, not else, if. Some languages, JavaScript, you'll get like the full word like else if. But for Python, instead of writing the whole statement else if, you just write a leaf for else if. Very simple. The last statement, of course, it's else statement. So that's it. Imagine that's it. If a leaf else statement. Let's check that example where we can get a good scenario right here. The third example here is just like this. The same example for the temperature. If the temperature is greater than 25, it's a hot day. A leaf, use the keyword a leaf, temperature is greater than 15, it's a warm day. Else, it's a cold day. Okay? It's a cold day. This could be nice if we write the code and try to understand. Temperature. Let me just paste it and build on top of this. Maybe we have set our temperature to 25, the variable 25. If the temperature is greater than, let's say 40, just a random number, we know anything above 40 is 41 all the way to a trillion. And above, that is greater than 40, no doubt. It's not a negative, it's greater than 40. But do you know between 0 and 40 what we have? No. So that's where the elif, let me just type that. So elif, the use of the keyword elif. Elif, the temperature is greater than 20. Of course, we know 20 is not greater than 40. So that means if the temperature is just like in between 21 and 39, so that the temperature is greater than 20, but of course not greater than 40 because we have this condition of greater than 40. We have another third option. We can add as many conditions as we want. Of course, we know the temperature can be greater than 10. So that means if the temperature is in between 11 and 19 and 20, that's a cold day. Of course, it's a cold day, right? It's a cold day. We can add as many as a leaf statement as we want. Okay. I want us to test something before you write the last condition. I want to run this code. It's a cold day because the temperature is in between. Wait, it's a cold day. Temperature. How is it a cold day? As you can see, it's giving us the wrong answer. We know a cold day from our program is anything below 10, right? So, no. Actually, this is correct. This is correct. Let me do 21. It's a warm day. Yeah, it's correct. It's correct. It's correct. It was correct. So, if the temperature is greater than 40, it's a hot day. And if the temperature is greater than 20, so that means it's 21 all the way to 40. Then it's a cold day if the temperature is greater than 10. So that means it's 10 and above. It's 11 all the way to 20. But we should have another final condition. If this temperature is extreme, we write the last statement as the else block. We write as the else block. Of course, we have the last alternative. That is, if the temperature is not greater than 40, so that means 41 all the way to a trillion, whatever number. Temperature is greater than 20. It's in between 20 all the way to 39 all the way to 40. It's a warm day. The temperature is 10, above 10 or greater than 10. So it's a cold day. So that means the temperature is in between 10 all the way to 20. But we are going back. The temperature can be too cold. If it's too cold, that means it's less than 10, of course. Then it's a freezing day. So if the temperature is just like that, it's a freezing day. So a quick recap. If statement is if we don't have any other alternative. If the temperature is greater than 20, it's a hot day. Else, nothing happens. We build on top of that if else. More than one alternative or more than one outcome. If the temperature is greater than 20, it's a hot day. But what if the temperature is less than 20? It's a cold day. The temperature can be negative 30, negative 4, negative whatever negative. But that's a cold day. But we want to make our system have so many options. Someone can know, now where do I lie? That's when we added the leave statement, because we have more than one condition that our system has to check. So basically, that's it for the conditional statements. As simple just as that. You see that? That's why I tell you everything is really simple and you think I'm joking. Okay. So I'm just seeing someone asking me to do one practical example, another practical example. I know if you are requesting for another practical example, that should have it the you should have understood that. And it's fun. So this is the exercise for the next example. You have been assigned some task to do students' calculations and award them scores, marks, grades, whatever. The maximum score is 100%, of course. Now, there is a student who will score between 0 and 39, somewhere there, right? That student can either have failed, right? But there's another student who will score between 40 all the way to 49 or 50. That student will have scored maybe a certain grade, like B or something. There's another student who is going to score between 50 and 60. Will have scored maybe C. Between 60 and 70, that's a B. 70 all the way to maybe whatever number that you are going, percentage that you are going to set, it's 100, right? They have scored there. That's your exercise. Try it out. Maybe a hint. Maybe let me give you a hint. It's just like this example. As simple as this. Assume this is the student's score. I'm not going to change the variables. Assume it's a student score. A student has scored greater than 70. So they have scored an A. You can add a statement to support that. A student has scored greater than 60. Maybe something like 60. That's a B. Greater than 50. Of course, we have another condition for 60, so it's not going to exceed 60. It's a C. Then that goes all the way to the least as you can. But we can add another condition here. If you don't want to be greater than, you can add greater than or equal to. Greater than or equal to. Greater than or equal to. Maybe you want to award the 50 mark as a C. So definitely you can add that, as simple as that. Okay, very simple. You can change these variables to just match your exact words that you want to match. It was as simple as that. Now, in practical, now when it comes to writing the systems, the actual systems, how does it happen? Or what example can we give? You're creating a system that the lecturers, your trainers, your high school teachers, whatever, you are doing your school assignment. They mark your exam, you have scored 50. They mark students B exam, they scored 70. Is it my task as a lecturer, trainer, or your teacher to know what you have scored and give you a grade, then start computing whatever, blah, blah, blah? No. I, as an instructor, trainer, your teacher, will just have to key in your student ID, maybe in a system, then put what have you scored. 49, I don't care. 60, I don't care. My task is very simple. Just input, then save. Next student input, save, input, save. Okay? A list of 5, 10 students. The system will compute itself and know that student A, student B, C, they have scored a certain grade. It's that simple, man. That's how we use these conditional statements in practical. Maybe you have stored what do we call your student ID in a database, right? And you remember last week we were talking about data types. We have unique data types, lists, sets, all those kind of things. Your student ID is unique. So your lecturer has to just key in your student ID, maybe the units that you are doing, and I'm done. Lecturer B will do the same. Key in your student ID, the units that I'm doing, or that me as a lecturer am assigned, then your marks. Lecturer C all the way to maybe 4 or 5 lecturers, depending on the units that you are doing. Then the system will compute itself and produce that, what do we call it, result slip, whatever, depends on how you call it in your institution. Then it will compute after every lecturer has assigned everything, they have confirmed everything set, then someone there, the system admin or whatever they agree, I don't know how they do it, but they will just have to press, now they will send all the results to the students in the system. You have scored this in this in Python, this in C, this in whatever. So that's an example of how these statements work. You can't avoid them depending on the system that you are working on. Very simple. You see, it's something that you can't avoid. And I think that example is relevant. Someone is saying that they have already done the exercise. They are very happy for the rest of the week. Very simple, very simple. So, how much time do you have left? Not much. So I think there is a topic that we are going to skip. Maybe we are going to do it next week as a reference. But we are going to see how much time we have. Because remember that we are working with our concentration span that we set to 1 hour. We set our concentration span to 1 hour. Remember that? I just want to stick with that, our concentration span. After that, you can shift your concentration span. Another topic, Python loops. Loops, they are still under conditional statements because you have to meet a certain condition. What are loops in computing? Loops are used to repeat a block of code when you perform a process of iteration or repeating task. An example will make you understand what I mean. But before you go to the examples, we have 2 types of loops that we are going to check for today. We have so many, but we can check 2. The basic ones that you can't avoid. We have the for loop and we have the while loop. That's what we are going to check for today. We have so many. We have provided extra resources right here to check these Python loops. You have so many loops, you can check them out. So we have for loops and we have a while loop. We are going to give an example and write code and see and try to understand what these loops are. So let's just start with the for loop. Then we'll keep understanding the kind of loops that we have. So in Python language, in programming languages like Python, we have 2 types of iteration or 2 types of repetition. When I mean iteration, just know that I mean about repeating, repetition, cycles, whatever you call it, but it's just like repeating. We have indefinite iteration or indefinite looping or indefinite repeating or repetition. But this indefinite iteration is where the number of times the loop is executed depends on how many times the condition is met. Leave it there. Leave it up to there. I know maybe you have not understood what I meant, but we are going to see examples and they will make you understand better. We have definite iterations. That the number of times a loop while executed is defined in advance. So this is what I mean. Let's say we have in a marathon, okay? I have to run, let's say in a small field, right? I have to run like 5 cycles. From where I started, run all the way to where I started, round 1, round 2, round 3, round 4, round 5. So that's what looping is. So what is the condition here? The condition is 1. I have to run 5 times. So that's the condition. Once I run the 5th time and I complete it, then the race is over. I'm done with my race. I can stop. I can rest. I can do other things. Okay? So that's what looping is with that example. The condition is here. I have to do it multiple times. Run from where I started, run again round 2, all the way to the last round. Okay? So that's what looping basically is. But what do we mean by indefinite and definite iteration? Indefinite iteration is where the number of times the loop is executed depends on how many times the condition is met. Let's say I have to run 5 times. The condition again is 5 times, but I have to run. If I run the first time, that condition has been met the first time. But if I don't run, I just walk, has the condition been met? The condition is here to run 5 times. It's not to walk 5 times. The condition has not been met. That's just a simple example that I can give. We are going to look at more examples while we are writing these codes and see how now in practical, in programming, how can we implement this. Definite iteration is where the number of times the loop will be executed is defined in advance. Another example, a different example. I've been given a punishment to run in that field. The teacher tells me, run all the way to here. Run the second time. I don't know how many times I'm going to run until the teacher is satisfied. Okay? But there's another condition, definite iteration, where before I start the loop, before I start running, I know the teacher has given me static number, run 3 times in this field. So that's what a definite iteration means. I know the condition in advance. I know how many times I'm going to loop in advance. Okay? I think I'll be spending more time on explaining these examples so that writing the code is more easier. And I think you guys, once I explain the examples, I think you're understanding it better than going straight to writing the code. If that's correct, you can tell me you're understanding better once I spent more time on explaining the examples rather than just going straight to writing the code. If that approach is well, yes, I think you guys are understanding both. So there are 2 types of people here who will go to the code, rewrite the code, and then they understand there. There are others who are going to get the theory, then once we go to the code, they get it better. So both works for me. So let's just write that code. So let's write our code here. The first is the for loop. We are going to write two loops, for loop, the while loop. Then the rest I'm going to leave you to maybe try them out. Maybe in the next session where you get stuck, you are going to see. Okay, let's week 3, 4. For loop dot py. Here, I'm going to define this example. I'm just going to use this example that we have in the LMS. Oops. What happened? Oh, escape. Okay. I'm going to have a list of fruits here. A list of fruits. Okay. Once we run this code, we are going to understand what this code is doing. So let me just write this code for you to understand. I'm going to use the keyword for. For a single fruit, do you write a fruit? Fruit. For a single fruit, sorry, spelling. For a single fruit in the list of fruits. So what am I doing here? I'm looping through. I just want to get a single fruit. So for a single fruit in the list of fruits, okay, we have a list here with different types of fruits, okay? But inside this list, we have single independent fruits like cherry, banana, apple. These are all fruits. So I want to loop through, I want to go through in this list of fruits, then take a single fruit, then print out the fruit. That's the logic. We have a list of fruits. I want to go to that basket with fruits, then remove one fruit, then go remove the next fruit, then go remove the last, then other fruit, the other fruit, the other fruit, all the way to the final fruit. Okay, so that's the loop. The loop is here. Go to that basket with fruits, take a single fruit, remove that fruit one, go again to the basket, remove the next second fruit, the next fruit, then that process repeats itself. So what are we looping here? The conditions here, take one, remove, take one, remove, take one, remove, repeating the same activity. So here, I'm going to print out the fruit that has been removed from the basket. Okay, then run, and we see we have removed our fruits. Let me clear this and run the code again. We have removed our fruits. So what is the code doing here again? One further explanation. I have a basket with fruits, okay? We have said the loop is just like cycles, and it's a conditional statement. So go in. So I'm going to take a single fruit in the basket of fruits, then print out one fruit, okay? So I've done the first cycle. It's a loop. I have to leave the basket empty. Have I printed out the first fruit? Yes. Done. Process done. Again, go to the basket, remove the next fruit, print it out here. Done. Success. The basket is not yet empty. Go back to the basket, remove the other fruit, then print it out. and we have looped successfully. S imbu, S A B C D. You can do this, you can get this, you can get this. I have a question. Someone is asking the question. On the first exercise of grades, is the condition for equal to or greater than? The condition is any. It's an open question. We are not restricting the condition that you can use. You can use equal, greater than, or equal to, whatever condition. It's open. It's an open question. Someone is asking, mine is printing out. Maybe you have copied this code. Maybe you have copied this code. Maybe there's something that you have missed in your code. There's just something that maybe you have written wrong. Let me grab a charger. Quick, fast. Okay, so that's what a for loop does. All this is just explaining whatever we just explained. You can check other examples of for loops right here. Once you understand the first example, the other examples will just like A, B, C, D. So these are just different examples of for loops. So let's check at the last loop, that is the while loop. The while loop. A while loop performs a set of instructions as long as the given condition is true. A while loop, again, only performs a set of instructions as long as a given condition is true. I'm thinking of the best example that we can give. Let's go back to the raising or the running example. No, that's not a good example. Let me find another example that executes only when the condition is true. Now, let's just check at this example. We'll understand from this example right here. Let's see what this while loop has to offer. Then we break it down further. We set our variable count of 1. That's a normal variable. Remember the variables that you are setting right here? Just like that, you just set a certain variable. Just an example. Then we write the while the count is less than or equal to 5. We can twist this. If the count is less than or equal to 5, while the count is less than or equal to 5, print the count. Then increment it by 1. We are going to write this code. Once we get the output, we are going to understand it further. But before that, let's just read through this explanation. We initialize count is equal to 1. So you just set a starting value. We call it a starting value. Okay. Then we set the condition right here. While the count is less than or equal to 5, keep the loop running as long as the count is less than 5. So this is what's happening. We have the starting count is 1. I want to loop as many times as long as we have the starting point as 1. That is the starting point is 1. Okay? Let's understand this. The starting point is 1. So, if the count is less than 5, keep the loop running. Run the first time 1. Run the second time, increment that plus 1 plus 1, 2. Okay? Run the third time. The previous answer was 2 plus 1, 3. Run the other time. The previous answer was 4, was 3. Increment to 4. Like that, until we get the condition is 5. Then stop the loop. It's as simple as that. So let's just write this example and say while .py. So we state the count is equal to 1. While the count is less than or equal to 5, we basically print the number. Okay. Then we increment the count plus equal to 1. This is where I know the problem is. Why do we have to plus equal to 1? Maybe someone has an idea before I explain. Let's check it, the code. Let's scan through this code again. The count is 1, the starting point. The count is less than or equal to 5. Then we print out the count. Then we take the count plus or equal to 1. Why are we doing this last statement here? Someone can explain to me. Maybe you can type a short text if you think you got the answer, or you can I'm just reading through this. I'm just writing increment until the count is 5. It's a conditional statement. It's looping through, incrementing by 1. We are looping until the given condition is met. Incrementing by 1, incrementing plus 1 until it's 5. Plus 1 until it's 5. Everyone is correct. Everyone is correct. Everyone is correct. So we are going to run this code and see the output, and then we try to explain the output. So let me run this code and explain what's happening here. So this is the output. We run the first time with the starting point of 1. Okay? Together. Go through the count. Print out the count, but increment that count with plus 1. Okay? if you are printing out 1, the next output that we are going to print, we are going to increment it by 1. So we get 2. Done. We run through the code. Then if the previous answer was 2, we increment by 1, 3. Same loop continues. If the previous answer was 4, loop again, increment the previous answer with 1, get 4. Process continues until this is the 5th time that you are looping. And because the condition is less than or equal to 5, that means 5 is included. The 5th loop is included. Okay. Increment by 1. The 4th, and it's just like that. What if we change the starting point to 2? Just an example. There's something that you're observing. 2, 3, 4, 5. The starting point is 3. Save, run the code. The starting point is 3. So basically means 3, 1, 2, whatever is the starting point. That must be included. So first, print out the starting point. Okay? Print out the starting point. Then take the starting point, increment by 1. The starting point changed from 1 to 2 because it's a loop. Take, increment by 1. And it's as simple as that explanation. It's as simple as that. Someone is telling me we try a weird thing here, like the count plus plus. As you can see, this is an expected expression that we can't use in Python. Let me see. Doesn't work in Python. So basically, it's just like this. So once we try out, thank you, Adabajo. You got the best explanation. Thank you a lot. I appreciate. That's why I'm here for you guys. That's why I'm here for you guys. So we have different explanations when it comes to different languages. There's different ways of writing these loops when it comes to different languages. Someone said we count plus plus in Dutch and also in other languages that would happen. So basically, that's it for the loops. The other examples are just an advancement of these conditional statements. So the rest, you can check them out. They have the same explanation. So I told you, here is the catch. The catch is basically simple for understanding these things. It's very simple. I know if I can ask a random person, I don't have to ask what a for loop or a while loop is. I just have to ask, what is a loop? And or you'll give me examples of cycles. Run the first time, second time, third time. If you get that, that's what a loop is. You are done. Imagine you are done with loops. The rest is just writing examples now. How does a for loop work? A for loop, a quick recap. We said, let me get the example. Oops. We said maybe we provide a list of fruits right here. Then you get a single fruit inside the basket of fruits. Then you take out that fruit. Again, you have a basket full of fruits. fruits. See, this is plural, fruits. I want for a single fruit in the basket of fruits. So this, grab a single fruit inside the basket of fruits. Then take out that fruit. Go back, go to the basket full of fruits, take a single fruit inside that basket, take it out. The basket is not yet empty. Go again to the basket full of fruits, take a single fruit, then print until all the fruits are, all the basket is empty. No fruit in the basket. That's what a for loop is. Same case happens for the while. Quick one for the while loop. Count. We stated a starting point. As long as the condition is not less than or equal to 5. As long as the condition is less than or equal to 5. First, print the starting point. Then go again to the loop. The answer is it less than 5 because we have printed out the starting point as 1? Yes. Take the previous answer, increment by 1. The answer becomes 2. The second loop. 2 is still less than 5. So I have another chance to loop through. Loop through. The previous answer was 3 that I printed out. The condition is not yet to be met because this is the third time I'm looping. Take the previous answer. That was the second loop. Increment by 1. Get the third loop. Fourth, fifth, until the condition has been met. As simple as that. You only need to understand that. You don't need to know how to write this code at first. This is your day one writing loops. Perfectly fine. You already know what loops are. You don't need to know the rest. How to write this code just like that from the top of your head. You don't have to know. But do you understand what loops are? You're 100% right. Day 1, day 2, day 3. Do the practice. Try more examples. By day 4, you already know how to write a loop. That happens to every single field. Every single thing that you need to do, you need to start from the basics. Understand how these things work, then build on top of that. Then you have them from the top of your head. You can just, everything is in your fingertips. You can just write. As simple as that. You don't have to give up. You are running the code, but it fails. Don't give up, man. It will still work perfectly. So we are running out of time. And as usual, you are running out of time. Application in real life. You guys, I think you are enjoying these examples. You want an application in real life. Let me think of the best application in real life. I'm thinking the best example. We have so many millions of examples. I just want to give an example with a demo of something that is happening. Example in real life. Not in real life, but example in programming. I know that's what you guys are requesting. I'm thinking of the best example. There we go. I got one. So I have a list of courses. Where are these courses stored? In the database, right? They are stored there. I want to fetch them from the database, from a collection or from a table of courses. then show it in your front end. Okay. So what am I going to do here? I'm going to write a code that goes to the database, to that table, check the first course, that is course index number 1. Take that course, bring it to the front end, display. Done. Have you done displaying that? Yes. Go back to the database, that loop. Check, do you have another course? Take it, print, fetch, and show. That time, how many courses do you have? 5. All the courses have been fetched. Display them right here. That happens. Maybe you might write the code and you don't see them displaying one by one. One, go fetch. No. It happens with, I don't know, milliseconds. I don't know the correct words to use. Is it nanoseconds? It just happened. Then you have everything. It has looped through and they are displayed before you realize. So that's basically what happens. And that gives a good example of the example that we gave for the bananas. Go to the basket, fetch, display, fetch, display, fetch, display, until you have fetched all the examples. So that's a real live example of how to use this conditional statement. And I hope that example makes sense. Well understood. Thank you, Stanley. Thank you, Stanley. Well understood. Thank you, Victor. Thank you, Victor. I think we are going to take less than 10 minutes to understand functions. So the rest are just building on top of these loops. I said once you understand the basic, everything is going to be as simple as A, B, C, D. So this is the topic that we said we are going to skip for a while. I think in the assignment you don't have this thing called list comprehension. In the assignment, in the quiz also, in the survey, you don't have this list comprehension. So I'm already aware of that. Maybe if time allows, we are going to get back into it. But let's go to the functions. Let's go to the functions. Functions, they are as simple as they sound. Functions. What are functions? A function. Do you remember the example that we gave of a block? The normal block, everything goes inside that block. You remember well. So a function, all functions are fundamental part of any programming language. I'm going slow for you to understand. They are fundamental. These are the kind of things that you can't do without. Functions. Of course, you can't do without variables, data types. These are things that you can't do without. If you like it or not, you're going to use one or two. So functions allow you to encapsulate a reusable block of code. To encapsulate a reusable block of code. Ignore the English parts. Ignore the complex words like encapsulate. Ignore them for now. But functions allow you to write a reusable block of code. What is that? What I'm trying to give an example of a good example of something that is reusable. A good example that we daily use. I'm tempted to give the example of a plate. You can use a plate, you can rewash, you can put some fufu in it, you can put some pilau in it, you can... No, I'm avoiding that example. I want to give a better example. Then Just a normal example in real life. Someone can give me example in real life. Don't give me an example related to programming. That we are going to get back to it. I just want an example of how you can use a function in real life or how we implement functions in our daily activities. Don't give me an example in programming. We are going to get to that. You just want to stand the basic. About so. How maybe you can explain. Someone can give me an example of a function. Yeah, someone is saying shoes. Shoes, we can reuse them. Yeah, thank you. Example of shoes. We can use this type of a shoe to go to sporting activity. We can use the same shoe to go to an event and flex with it. We can use the same shoe to go to church, mosque, the same shoe. We can use the same shoe to run and do some sporting activity. But also our mothers, our guardians, they use shoes to discipline us. So a shoe is a good example with different, it's a function that you can use it in multiple occasions. Thank you for that example of you say carry water, you can carry juice, you can carry milk. Yes, those are examples. Thank you for the examples. You guys are attentive with these examples. Yes, these examples are all relevant. Shoes are used for disciplining. Perfect, a perfect example. Thank you, Stanley. Someone is wondering how do shoes used for disciplining people? You guys are wondering. You cool kids are very like you don't know, you don't understand. They are very disciplined. So this is how they used to discipline uh, kids. Maybe your parent is trying to show you a direction. You see, go and fetch water. Where? There in that tank. Okay, they use the shoe to point um, the direction. You get it? Forget about it. So they use the shoes to show you direction. No, 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 no. They slap you on your face with the shoe. From there, you'll know the direction by yourself. In case they point that direction and you don't see it, they slap your eyes. Then the shoes will ignite some magnetism. Then they will guide you. The shoes have some Google direction, some kind of thing. You don't understand. You don't get it. Unless they have been used, you'll get it. You'll get it. That example is a good example. So let's get to an example in programming, how you use functions. I'm tempted to demo that example. So let's say, so let's just read this example and then we are going to give an example of how you use functions in programming. A function is a block of code designed to perform a specific task. In programming now, a function is a block of code that is, I insist, designed to perform a specific task. That's why we insist, perform a specific task. An example of a task in programming. Let's go to Facebook. You have a function. When I scroll through the content, I can like. You see that functionality for like. Double tap to like, whatever, how you like it. That's a normal function of how you use a function. A simple function is designed to do what? Perform that specific task. What is that specific task? Click and like. That is the specific task. So that's a good example of how functions are used in real life. I can create a small function that does what? That submits my assignment in the LMS. So there's an input field that I just have to paste the link for my assignment, right? So once I paste, what do? I click submit. So we have a function that does that. That listens to that I've clicked a button. Then now the function will know I have to submit this assignment. So what will the function do? The function will do this. The function will check the input field if it's empty. If the input field is not empty, it will check another condition maybe. Whatever you have pasted there is not a paragraph, it's not a text, it's a type of a link. Then if you meet all that condition, click submit, no errors, submit. As simple as that. But if you try to submit an assignment that you are already submitted, what error do you get? This assignment has already been submitted. You see, that's a function. Do what? Going to the database, fetching and seeing this particular person has already submitted the assignment. So what can I do? I can tell them, sorry, you are trying to submit this, but you have already submitted. But you still have an option to edit. You just go to your assignment submissions and then you edit. It's as simple as that. So that's how normally functions work in programming. We're just going to write one example of a function. Then we are going to call it a day. I think you have run out of time. Example, then we call it a day. So in functions, we have two types of functions: built-in functions and user-defined function. Built-in functions are like predefined functions, e.g. print, type, learn. So do you know that we have been using functions without our knowledge? We have been using print. This is an inbuilt function in Python. So once I place my cursor right here, you can see it's saying print the value, blah, 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 blah. This is a function, define print, whatever, that's all that things. So this is an inbuilt function. Imagine all the days from day one, we have been using functions without our knowledge. So this print, it's a type of inbuilt function, and many more that we use on a daily basis. But what are user-defined functions is what we want to create now. So user-defined function, we have things like the function name, parameters, then just those two. I want us to emphasize on those two. Functions, parameters, and the block of code. Okay, block of code. So to define a function, let me just go straight to the example, because now you already know what functions are. Functions.py. Okay, we are just going to write this one example, then we stop right there. So how do you define a function? You define a function with the def keyword, a function, and I can call it my function. And this function, I'm going to add some few things right here. Then I'm going to explain what this code is doing. Then I'm going to print my function. I'm just going to demo something small, then we do that. So that one doesn't work like that. It works like this. You print out the function. Just a minute. There we go. So we have the output ready. We can explain now the syntax of writing a normal function. So we use the def keyword to define a function. Define my function name. Any function can be add, sum, whatever function that you write. Okay, can be whatever function that you write, function name. Then followed by these brackets here. Inside these brackets, we write something called parameters and arguments right here. We are going to see the difference that we have here. Once you write one, we are going to see what it is. Then full colon, then anything inside, as long as it aligns with that, it's a block of code inside the function. Then we have a function. Instead of using the print my function, we write just the function name enclosed inside this, not enclosed, but followed by these brackets. So you have to write a function and you have to call the function for it to work. So that's the concept of functions. Write the function, then call that function right here. I want us to, in 2 minutes, we are going to finish in the next 2 minutes, 11:43, so you are going to 11:45, 46. So I want us to quickly see this example right here. Yeah, this example right here. The example for this one right here. I want to write a function that adds two numbers. These two numbers are A, comma B. I'm going to explain. Don't panic. Don't panic. So here I'm going to write a function that takes the sum of A plus B. Okay. Then I'm going to print something like this, and I'm going to do away with this. Okay, something like this. So what is it doing? This one we call them parameters. Parameters. Okay, then you take the parameters right here and you add the two parameters. You just define a variable called A plus B. We know A is this plus B. Then we print out the output. If you write parameters, you must pass the arguments right here. And here we add 2 plus 4. I want to run the output and see the sum is 6. Then I will explain what is happening. If you pass parameters here, you must pass the arguments right here. Okay? You write here. So I want to interpret this code. We have 1 minute now. I want to interpret this code. So this code and this is basically looking like A is equal to 2. B is equal to 4. So basically this code is looking like this. This A is assigned to 2. The first one is assigned to the first one. The second is assigned to the second one. So A is 2. So A is 2. B is this one. So take these ones as, what do we call this? Variable, and the value for that variable. So take this one as the variable and the value for that variable B, the value for that variable B. Interpreted, it looks like this. And interpreted further, it's just like the sum of A plus B. Then you print out the sum of A plus B. Imagine all this code is the same as this one interpreted. So let's change this. Instead of B, let's say to R and T, so that we get the difference. This one to be 5, this one to be 12. Then this one is R, and this one is T. Print out the sum of just a variable name so that it won't confuse this and this. Then the sum of, maybe let's say that, print out the output, and we have the sum. The first one is 6, the second one is 17. Imagine all this code is the same as this one. Define a function, my function, pass the parameters here and the arguments. The sum is A plus B. It's the same. R is equals to 5, T is equals to 12. Sum is the same. Then print out the sum. But only because it's a function, you have to call that function name. Then you enclose it inside those brackets. Then you add the arguments right there and past 1 minute. Imagine that's it for today. I know we have left with so many examples, but remember that wanted to keep it short. So we are going to organize another catch-up session. Of course, Wednesdays we don't have sessions. So tomorrow we are going to have a catch-up session. This one is true. I promise you that. You're going to find me in the catch-up sessions. I think you guys have enjoyed the examples. If you have enjoyed the examples that we have given, kindly let me know. Kindly let me know if you have understood with the examples that we have given. I think the examples made everything simple than the examples make everything better as compared to other just going straight to writing the code. Thank you guys for all these comments. I love them. Thank you guys, I appreciate and imagine the session is over. Stop